this is going to be actually even further away. This is actually an effort that's not particularly to do with MCORD at all, but it is to do with wireless. So I'm going to talk to you about a project activity that's going on called Wireless Transport Modeling and Implementation. And I have to apologize, this about 2/3 of the slides are from Tracy Van Brakel of AT&T, who's actually part of the wireless transport subgroup. And so I'll present them, but I may not have that much detailed information about them. So I chair a group called the OTCC, or Open Transport Config and Control Project. And that is kind of more on the standards or software-defined standards side of ONF. It is not intended to develop, open source software that someone can take, so much as it's developing models and APIs. So our focus is particularly on transport technologies. We have a lot of work going on in OTN and photonic media modeling. You can see there's a number of different subgroups there, but in particular there's a group that's doing wireless transport modeling that is looking at modeling of the wireless transport equipment and how they use the radio spectrum and how you would retrieve information like performance monitoring information and so on from that. And so they've developed a model which has already been published as ONF TR532 on the bottom. There's another TR545, which I'll talk about it a little bit later, and there have been a number of wireless transport proof of concepts. So to give you kind of a real overall perspective, this is all tied in with an activity in the Open Information Modeling and Tooling Project, or OIMT, where they had been working on something called the Core Information Model, and that's ONF TR512. But this is sort of a technology agnostic, sort of a very high level modeling framework that gives you a set of patterns and methods. It's intended to be something that can be applied to a lot of different technologies, but to be kind of a unifying model across them. And Nigel Davis, who's a co-chair of that project, is going to be giving a more detailed talk about that at 5:30 tomorrow afternoon as part of the ODTN track. I mentioned that we have a lot of photonic modeling going on, so that's tying in with the ODTN project. And you may have seen the ODTN demonstration in the expo room as well. So this information model, or core information model, then feeds into a variety of technology-specific work. There's a project called the Transport API, which again is tied in with ODTN, and there's going to be a talk about that tomorrow at 2:30 in the afternoon on the ODTN track. Then there's various transport modeling efforts going on for things like OTN, photonic media, Ethernet, and so on in another subgroup. Then, as I said, there's this wireless transport group. All of these projects, the models are aligned back up to this core information model, but it's all a bunch of extensions and augments for providing the details of a particular technology. And then there's one project which developed out of that device management, and as I said, I'll talk about that a little bit later. So the goals of wireless transport are basically to extend SDN for wireless transport networks. Now, wireless transport networks are not exactly networks in the sense of you have a mesh or something like that, and there's like wireless transport switching going on. Wireless transport systems are basically kind of point to point, and then you need to go up a layer in order to switch between these systems. But when this work started, there really wasn't any model for the wireless transport systems. And so it was kind of a trail-breaking effort to develop these models. There is an open source software site. There's a GitHub site called Centennial. That's where the the models and associated software are stored, so they're all publicly available if people want to have a look at them. And as of the beginning of this year, there had been 5 proof of concepts. There are a number of carriers that are very interested in this that have sponsored these proof of concepts. They're multi-vendor. The basic setup for the proof of concepts is to have a number of microwave vendors bring in their devices, use the information model as using a netconf yang interface up to an SDN controller. The group started off with ONOS as the SDN controller, or transitioned to ODL as the SDN controller, but it could be either one. Generally, so there's a consistent API between the SDN controller and the microwave device that may be directly to the microwave device, or it may be through some mediation software. But that's basically, as the proof of concepts have gone forward, more and more aspects of the microwave media have been incorporated into the model and tested. So this DMIP, Device Management Interface Profile, so that's something that came out as really a result of the testing. What people found was when they were doing the proof of concept testing, they had the same model, they chose netconf yang as their protocol, and it still wasn't interoperable. So essentially they had to make further agreements on how they were using netconf yang, what were the semantics of things like, you know, completion, success versus failure, and things like that. So it was decided that what you really wanted to do was create a document that had additional requirements for the implementation that would help you with eventually being interoperable. And so this was actually kind of following this idea of software-defined standards, because this actually came out of the testing of the software that this additional standard, TR-545, needed to be created. And that's now been approved this year and published as of October this year. So it defines things like semantic rules, as I said, defines how to implement particular options of the standard, in this case an IETF RFC 6241, performance and resource consumption requirements, and so on. So that is now published and was part of the proof of concept. So now on to the proof of concept itself. So as I said, we had 5 proof of concepts as of the beginning of the year, but the last one was really sort of a variation on the 4th proof of concept. So this now is considered the 5th proof of concept, and it was held in Munich, Germany last week. There were a good number of vendors, 8 microwave vendors, 8 application software providers, 3 optical vendors, and the 3 telecom operators that have been kind of mostly driving this process, which were AT&T, Telefonica, and Deutsche Telekom. And you can see, you know, here's a list of all the different participants. If you look down in the lower corner, there's actually a website where you can find more details about, for example, what each of the participants was providing, what were the different use cases for the proof of concept, and so on. So again, the intention was to validate this wireless transport model, ONF 532, which is now in release 1.1. Also to test implementations of this DMIP interoperability profile. And also there's ongoing work on Ethernet PHY modeling, you know, because in a lot of cases it's Ethernet going across the wireless interface. So there's an Ethernet PHY model associated with it. There was also some testing of the photonic model. I mentioned there's a photonic model activity. Even though this was mostly aimed at wireless, there were a few vendors that wanted to test the photonic model as well, so they tested that. And then run applications on top of the ODL controller. This is maybe, this is just a variation actually on the architecture you saw before. So it more specifically shows that Open Daylight Oxygen SR3 was the controller, that you had optical vendors, microwave vendors, and again, it was using this a netconf yang interface using the microwave model either directly down to the device or through some mediation software. And in terms of the way the proof of concept was carried out, so there was a period of testing, then there was a one-day forum to kind of present what was being tested, to discuss what each vendor or participant was doing within the proof of concept, and a readout event. This was actually presented on YouTube, I think, so I'll have to check and see if it's still available for people to see. But there were at least, I think, 50 or 60 participants in the test, so it was quite a large group. And I think there were something like 37 contributions that people brought in. So it was quite a wide range of not only microwave equipment, but also test applications. And the proof of concept itself, again, it's intended as a part of the process for achieving interoperable standardization of this API, of this information model. And so it's expected is that as the proof of concept feeds back, to the development of the standard, eventually the standard is released as a new version. Currently, I think I said we're on version 1.1, but they'll probably have a new version pretty soon. This, unfortunately, I'm not sure exactly what it's showing, but I think it's just showing a screen capture of an ONAP representation of the different wireless transport devices and how they're connected together. I wish I had a little bit more information about what that actually is, but if necessary, I can find out more about it. So what happens next? So the testing in the wireless transport proof of concept, as I said, it was last week, so it's really fresh stuff. It sounded like it was quite successful. I wasn't there personally, but then the next steps are, the 1.1 release of the microwave model was validated by the proof of concept, so that will be published as an update to the original TR-532. The group will take requests for modeling extensions for new services and collect feedback. There'll be a white paper that will be written up about it, probably, and published on the ONF site. And the other thing is that this activity there has been a lot of work now to integrate this work into ONAP and some other initiatives. This is just a screen capture of people happily testing. You can see it's quite a large group of people. It looks like maybe it involved multiple rooms, and all thanks to Telefonica for sponsoring the location for it. So ONAP. So Tracy in particular, it's unfortunately she can't be here. She got sick, and I think maybe while they were doing the testing in Munich. But she has been very active, and AT&T is very active in ONAP, and she's been very active in bringing this work into ONAP and tying it into the development in ONAP. So this wireless transport proof of concept was actually tied into an ONAP release 3 proof of concept. And they were, in addition to the wireless transport piece that was being tested in Munich, there were other related tests of ONAP and ONAP applications that were going on elsewhere. And if you look at this version of the table of proof of concepts, so again, these are all of the wireless transport group proof of concepts. But as you see in the second column, starting with the third proof of concept, you start seeing that it's not just the SDN controller and the wireless transport devices, but these are now being incorporated into the sort of wider framework where there is an orchestrator, initially eComp, but then as you go further down, it became ONAP Release 0, ONAP Pre-Amsterdam Release, ONAP Beijing Release. That was at a second quarter this year proof of concept held at AT&T, sponsored at WinLab in New Jersey. And then this most recent one in the yellow or gold lettering was ODL Oxygen and ONAP Casablanca. And beyond the wireless transport participants and wireless transport testing, you can see there were a number of other organizations and a number of other carriers that were involved in the ONAP piece of it. So you see Bell Canada and Geo and Orange, Telstra, Verizon, et cetera. And there are also additional functions on the ONAP side that were being tested in the ONAP proof of concept. So this has now become a part of something quite a bit bigger. Yes?
The most significant thing I noticed on that, and I didn't know about it, is Open 1.0. You see that?
Open ROADM 1.0. Oh yeah, so that, I was kind of a little surprised at that too, to be honest, because I thought this was a wireless transport proof of concept, right? But then there's this optical component too. And so I'm still actually finding out more about what exactly they did. I know that they did was they took the transport API photonic model, but they didn't, I believe that they used the Yang model and they ran it over netconf Yang to talk to the transponder device, I'm assuming. So I'm not sure exactly what they did with it, but you know, hopefully there'll be some more about it in the white paper. This is just a list of some of the 5G ONAP Release 3 5G use cases that tied in with the testing, so you know, real-time performance monitoring information, physical network function, you know, the wireless box, physical network function, software upgrade, plug and play, and so on. So that was in the last round of testing last week, and then Tracy included a preview of ONAP Release 4, which is, I guess, Dublin, and some of the use cases that have been proposed for Dublin. And so ultimately, some of these use cases are going to factor into the next set of proof of concepts for the wireless transport work. And then the last slide here is, this is actually Tracy's, because it's actually, I think, fairly AT&T focused. So AT&T has an initiative that they call Open Source First, which, as I understand from Tracy, basically the idea is use open source software as the default. So go to that first, and then only if that's not available do you kind of try and do something on your own. And that is they're tying that into a number of different community labs in North America. There's something called T-Lab and AT&T Advanced Technologies. There's Multi-Geo Labs, Wind River, and then WinLab, which has been used before for wireless transport testing. That's actually at Rutgers University in New Jersey, and now that's part of a larger effort they're calling Cosmos, which has actually not only Rutgers but also ties to Columbia and NYU universities in New York City. So just a kind of preview of some of the open source test beds, I guess, that are going to be coming out. And that's basically it. That's gives you an update of what's been happening. There's been a lot of work going on As I said, there are three main operators that have been driving this forward. There are a number of wireless transport, kind of most of the main wireless transport vendors that have been involved. And as it's gone along, it's developed from initially just a focus on the wireless transport, the modeling of the wireless environment, to now kind of having that brought into this broader framework with ONAP as well. So that's it. As I said, if you want more information, there's a number of links to websites that are in the presentation, and I'd be happy if anyone has any immediate questions to see if I can answer them, either directly or I can refer them to Tracy. So, any questions? Yes, Paul.
Here you go. Thanks.
Yep.
Thank you. It's a small room. Thank you, Lyndon. So that was very interesting, and it was conducted in Munich, and the gear was my company's and then became Infineris.
Mm-hmm.
So I was happy to see that, and I saw some guys there. But one thing I puzzle about with all of this is, if you look at the last slide, there's SIM 1.1, a 2.1, sorry, not the last slide, last slide of this, yeah. Well, this is probably not a good one. It's open mode in 1.1. Somewhere you have a SIM 1.1 and a photonic model 2.1, blah, blah, blah. Mm-hmm. And it seems to me that there are different components in different release states involved in these activities. And I wonder what your view of the kind of reconciling them to a single release vehicle that I can go and pick up and say, hey, this is all the stuff that was used there. And these, of course, are proofs of concept. So moving beyond that, how do you get to the sort of stuff that people have been talking about earlier today, where there are release exemplar implementations, I think. Could you talk about that?
Right. So as far as the models are concerned, I mean, I think that it may be a little bit confusing, because you have the the core information model, right, which is kind of technology agnostic, and then you have TAPI, which is a particular implementation of it which was really maybe originally designed as the northbound interface to the transport SDN controller. But then there are these various models, the technology models that have been kind of developed really jointly between the OIMT and OTCC groups for particular technologies. And I think they fit into TAPI in the sense that they can be used as at the northbound interface, but really they have more general potential applicability, right? I mean, that was why there's a photonic media model in TAPI, but what they did in the wireless transport demo was not to use it at the northbound interface, but to use it at the southbound interface over a netconf yang interface, or netconf interface. Similarly, so there's the wireless transport model, and that's again an implementation or an extension of the core information model for a particular technology. And that is being used at the southbound interface. Conceivably, that same information might be useful at the northbound interface as well. So I think what it is you kind of have a number of different components, and some of the components could be used in a northbound interface for a particular application, or it could be potentially used in a southbound interface. So it's more like you now have a number of different components, and you can start potentially using them in different places.
Okay. Thank you. You didn't answer the question, but what was interesting in watching you do it was I would have probably said exactly the same thing, and I think it illustrates a kind of quandary or a problem, if you like, or a work in progress situation. That's all, because I struggle with the same things, and actually looking at this, I might even go and argue with the title of the slide, because we have here models and interfaces, implementations of them mixed up, and I think that's part of the difficulty we have. Thanks,
true.
Linda.
That's true. Yeah, so Kartik will talk more about TAPI, but there's also portions of, TAPI's also been sucked into MEF as part of the Presto API, and that's another specification, right? So, yeah. So I mean, it's good in the sense that it seems to be popular as a platform for people to build on. I guess maybe one of the downsides of that is now you're starting to get sort of pieces of this in different places.
I got told by someone 5 different ones that are essentially supposed to be the same. Some of them are quite well.
Okay. All right, any other questions? All right, everyone wants to go to the reception? All right. All right, thank you very much for your attention anyway.